Hi, everyone. I'm Lin Chen. I'm your teaching assistant for this class. And I think it's time, but let's just wait for one more minute to let more students join. Okay, so today, Jason and I will hold the recitation session for you, and we will go through the very basics of Python and also some the very basics of the Python library, scikit-learn, and hopefully that will be useful for your homework and also the future projects. There will be 3 recitations in total throughout the semester. The second one we will review on some machine learning methods, I believe, and the third one is a guide to the project, and we'll also walk you through how to use other libraries such as PyTorch so that you can use them for your projects. Since we don't know about your background in Python, so we will talk about the very basics. And it's okay for you to don't know about basics, and it's also okay for you to know them. Okay, I'll just share screen now. Okay. So first, I'll talk about some FAQ about Python. When you first start learning about Python, you might wonder, what is it? Actually, it's like other programming languages. It's a programming language that lets you work quickly and also integrate systems more effectively. And you may also ask, why do we use Python instead of like R in our class? Well, actually, R is also an option, but we prefer to use Python in this class because Python is a major code language for machine learning, and also it has all the libraries with almost all the tools you need for machine learning. And also it's very user-friendly, it's easy to pick up, and whenever you don't know how to code or you don't know how to use a package, you can just Google. And as for how to use Python, you need a code editor or IDE, which is integrated development environment. So personally, I would recommend using PyCharm, Visual Studio Code, like others might be Spider. And in this class, we can use Google Colab. So Google Colab is basically an online code editor for Python, and you don't have to set up everything by yourself. And for more recommendations about the IDEs, you can refer to this link, because this link basically tells you all the advantages and disadvantages of each IDE. And personally, I use PyCharm because I think it's user-friendly and has a very good user interface.
Link, can I add something?
Sure.
So some of you may not have like a decent computer, and this project that we have, this final project we have, will probably require you to run large amounts of data, which is why we recommend that you use Google Colab. And because Google Colab, it doesn't matter what you're running it on, you're just running it on Google's cloud server. So they have all the packages downloaded and you're using their system instead of yours. You just have to be able to get onto Google Colab, the site. And to get onto this it's pretty easy. Just go to Google and type Google Colab, and it's probably the first link. So yeah, so if you don't have a good computer, we recommend using Google Colab to do the project.
Yeah. Okay, so I'll talk about the basics of Python part, and Jason will then talk about how to use in a scikit-learn the library. And so to know the basics of Python, first of all, you need to know variables. So the very first type of variable that you might need to know is a number. So like you do in calculus, if you want to assign like an integer to a variable, you just type x equals 2. And here, because 2 is an integer, if you make x equal to 2, then this variable is also called int. I actually have one thing to add. So this is the interface of Google Colab. You can add texts to it and also add code to it. And to run the code, basically you just use Shift Enter and run anyway. Oops, what's wrong? Okay. Okay. So now let's print x. So print is a very useful built-in function in Python. Unlike R, you have to print something to show it. So let's print x. Yeah, it's 2 because we assigned value 2 to x. Another type of number is called float. So to assign to make a variable float, you simply add this decimal points to it, and then y is a float type of a number variable. And about the basics operators, they're basically the same as in other languages. So you can calculate their sum, and also you can calculate their multiplication. And one thing that might be a little bit more special is its power function. So to calculate y to the power of x, you just use 2 times. And then let's run it. Yeah, since x is 2, y is 3, it makes sense, right? So other operators can be like division. This is the classic division. And this with 2 slashes is called floor division. So basically, it only returns the floor value of this division. So it only returns the integer part. And this is called modular operator, which returns the remaining part for the floor division. And let's run it. Okay, so this is number. And for the string part, string is a very important variable in Python. And to make something a string, you just use the quotes. Say, the name is Alex. You can print name. And one thing that's closely related to string variable is the input function. So say input function with quotes. Inside of the quotes, you type in the question that you want to show in the interface to. Basically, this is the question that shows up later for this input function. We'll see. Okay. Okay. So basically, this shows up. So you need to type in your input. Okay, let's say it's called machine learning. Okay, so nothing happens because we didn't assign this input to a variable. So say you can also do this. So you whatever you put into this box, it's assigned to this course variable. Okay, so let's do this again, machine learning. Okay, so now course is machine learning. And another thing about string is that the very easy way to combine strings is simply to use the plus sign. Okay, so if we want to make, if we want to combine several different strings, just use plus. Okay, so we have this sentence. And for all variables in Python, they have their own built-in functions, built-in methods, such as you can see when you type this dot, you can see there are all kinds of methods for this string variable, and here we'll use find. So this is this method returns the index of the string that you put in. So say we want to find where the first I is. It's at first index. And for string, sometimes let's name year birth. Okay, which is input. So one thing to notice is that anything assigned assigned to a variable using input function is a string. So sometimes we want the string to be a number instead. Okay, so say it's born, the birth year is 2000. Sometimes we want to convert it to a number, so we just use float function. It's this very similar for other conversion functions such as int, such as string, and since now it's a float, we can use the operators for numbers. The age is okay, and we print age. Okay, so now it works. But we can also try not using the float function. So birth year here is a string. So it will give you an error because you can't do operations between numbers and strings. Okay. So let's put it. Another type of variable is called Boolean. So basically Boolean is true or false. So say if this class is in person, we can, now it's not, so it's false. And you can print, sorry, print is person, which is false. So another thing about Boolean is that it's closely related to integers actually. So for false, if you use the int function, it will give you 0. And for true, the int function will give you 1. Here, not is just a inverse of false. So not false is true here. Another example is when you use logical operators, it also gives you Boolean variables. Say we want to know the relationship between x, y. So x here is 2 and y here is 3. Okay, so let's compare x and y. So it's true. And other logical operators can be equal. So you need to distinguish this between the 1 equation mark and not equal, and also less or equal to, etc. Okay, now let's move on to if statement. So oftentimes we will need to use the if statement to when there are several occasions you need to consider. So let's name this variable temp, which is temperature. So now let's say, which is not true, but let's say the temperature is 32 degrees and Celsius, and let's write a if statement. Okay, so if the temp is larger than 30, then print it's a hot day. You can see here, after I write down this temp larger than 30, I use this mark, which is very essential. And if it's not true, then we can use elif, which is short for else if. So elif means that temperature is less than or equal to 30. So if we elif temp is larger than 20, so inside of this condition, the temperature should be between 20 and 30. So we will say it's a nice day. We can even add more conditions to this. So elif, so temperature is larger than 10. We can say it's a bit cold. And last, we can use else. Print it's a cold day. I'm sorry. Oh yeah, actually another thing to notice is that if you want to use this single sign, it's better for you to use this, because otherwise Python might not recognize which is which. Okay, let's run this. Because temperature is larger than 30, it's a hot day. Let's try 15 maybe. Yeah, it's then it's a bit cold. For another part, which is loop, I'm not sure if you know there are 2 basic types of loops. The first one is called for loop, and the second one is called while loop. So for for loop, basically you just go through every variable inside of this list and do the operation. Say here, range 5 is just an easy way to get 0 to 4. Another thing to note in Python is that so for range, say range 5, it's 0 to 4. And also for indexes, all the index in Python starts with 0 instead of 1. So here, this is a for loop. Let's run this. And basically it returns, it goes through every value in this range 5 and print this value. Another type of loop is while loop. So for while loop, it's a little bit different because you have to assign an initial value to this I. So while loop, as it indicates, while it satisfies some condition, you operate this procedure. But you have to notice that you have to change the number of I here. Otherwise, this will run forever, because if you don't have this line, I0, then I is always less than 5, and it prints I infinitely. Okay, so this is while loop. We can run this. Another trick here is that I equals I plus 1. It's the same as I plus equal 1. We can try this here. It's basically the same. Yeah. So another very important part about Python is some of the structure variables. So the first thing I want to talk about is lists. So lists are basically variables where you can put in multiple values in the variable. Okay, so I'll name this variable as classes equals. So to construct a list, you should use this square bracket and put in the values for every index. Okay, so let's name. Okay, let's talk inference. Probability. Okay, so here we have a list variable with 3 indexes. If you want to access the value of certain index, it's very easy. You still use, classes. You still use the square bracket and input the index. So 0, 0 here is basically the first index. So it's machine learning. Okay, and let's say, yeah, another interesting is if you type -1 here, it accesses the last index, which is probability here. You can also change. The thing that you can also change the value inside of every index. So say you want the first class to be Python instead. You just assign Python to 0 index of classes. And now classes has changed. Sometimes you might also want to so sometimes you might also want to append append something to this list. So here we add a class called regression, and let's see what happens. As you can see, regression is appended to this list as the last index. And apart from, sometimes you might not want the thing to be appended to the lists. You might also want to specify which place it goes to. You can use insert instead. Sorry, insert. So the first one, as you can see here, the first one is the index, and the second one is the objects. So let's say I want to place something in the first index, and it's called math. And so let's print it. Yeah, basically math is in the first index now. Well, as I just mentioned, range function, it's also a very convenient way to construct lists for numbers. So say we want to have a list of numbers starting from 5, and it's less than 10, and we want every 2 numbers. So let's look at, let's see what it turns out to be. Let me assign this to numbers. And for I in numbers, print I. As you can see, we have numbers from 5 to 10, every 2 numbers from 5 to 10. So the next 2 variables that I'm going to talk about might not be so common right now for you to apply in machine learning, but I still kind of want to talk about them because they're still the basics. So dictionary is basically you want a variable to have multiple arguments. Say so we have customers, and it's quite a bit of a burden to assign name, age every time. So we create a dictionary called customer. So you use this bracket here, and inside of the quotes, you have the name for the argument. So say the name argument for this customer dictionary is, let's say, John Smith. And let's say its age argument is 30. Sorry. Yeah, one thing to notice is that you need to use a comma here. And okay, let's also have a Boolean Boolean variable is verified. Okay, so now we have this dictionary variable. If you want to access, let's say in the name part of this dictionary, it's very easy. Just use the brackets and type age. It's printed. Okay. And also you might want to change the value of the of certain arguments. It's still quite similar to what I talked about before. Okay, let's change its name to Jack Smith. And now let's print customer. Oh, sorry. Okay, now you can see the name here has changed. And the second part of this, I'm sorry. Another thing I want to talk about is tuple. But actually, it's very similar to lists. But the thing about it is that you cannot change the value of it. Let's say we use the parenthesis here. Let's say it's 1, 2, 3, 4, and let's assign this to it. And if you want to change, say, the first index to 0 instead, it will give you error because you can see this object does not support item assignment. So when you want to deal with, when you want to assign the variable to the data that you have, and you don't want it to be modified by accident. So that might be when you want to use this object. And the last thing I want to talk about is how to use libraries. So it's quite simple. If you want to, so there are some built-in functions in Python, but oftentimes we want to use like machine learning methods and some other algorithms that are not built-in functions. So we might have to import Python libraries and use the functions in the libraries. And in order to do that, you have to import the libraries first. So it's quite simple. So I'll just use the NumPy library, for example. As you can see here, there's no error. So that means NumPy is already downloaded. This is also a very good feature about this Google Lab because most of the common libraries have already been installed. So you don't have to install them by yourself. And you can just import them when you need them. So here, let's say import NumPy. And another thing you can do is, maybe you don't like the name NumPy, it's too long. You can say import NumPy as NP. So now, whenever you want to use the library, you can just use NP. If you don't, sometimes the libraries can be quite large, and if you don't want to import everything in it, you can, and if you only need to use, like, say, a certain function in it, you can say from NumPy import shape. Okay, so we have the shape function from NumPy now, and we can use the shape function whenever we need. Okay, let me actually give you an example. So A here is an array. You can see here I used NP. I can actually also use NumPy, but because I imported NumPy as NP, I can use NP now, which is quite easy. And let's name it. Okay, this is a two-dimensional array. Okay, we might want to know the shape of it. So say a dot. Actually, let me run this first. You might want to know the shape of it. You can print a dot shape. As you can see, all the building methods inside of A, because A is an array in NP, so it has all these building methods, and we want to use shape now. Yeah, it's 2, 2. And another way to use this is to use the shape function, because we already imported the shape function from the library. So let's say shape A, it's 2, 2. They're basically the same. So this is what I wanted to talk about the basics of Python. And I think Jason will take it from here.
Right, so I'm going to talk a little bit about scikit-learn because it pertains to your homework 5. Let me share my screen. So I think the homework is probably more easily done on, it's probably more easily done on your own IDE, like PyCharm that Ling showed above, PyCharm or Visual Studio Code, because looking up how to import data set, I don't know if you guys looked at the homework, but one of the files is like 1 GB large. I think you have to maybe upload that to Google Drive and then import it here, but importing stuff, data sets, will probably take a long time. maybe there's a way to call it from your Google Drive, and that's pretty quick. But it might be better for you to do this on PyCharm. Let me just quickly go over how you would call a data set in PyCharm. So let me share a different screen. So this is right. So hopefully you can see my PyCharm screen. So you know that this homework file was called homework1 q5x.txt. So wherever you save it, you have to define a file path. And this function, I think, will be pretty useful for importing the data set. There's a way to just import data set through the IDE. I wouldn't recommend that because then the IDE takes a long time to process it, and you might be waiting for like 20 minutes to an hour for this file to load. This actually, if you just do this, this actually runs in a few seconds. Now, just something that you would need is NumPy. You see Ling mentioned that you can import NumPy as NP if you don't want to write out this abbreviation, like if you don't want to write out NumPy, which is pretty cumbersome if you have to do that every time. So you can use this abbreviation NP for NumPy, and NumPy has this nice function called load.txt. So you see that we have a txt file for the homework. So you just load this file. Delimiter is one of the function parameters of load.txt, and it just means this is just asking you, how is this file separated? So how do you tell the difference between the file values? And I don't know if you can see my screen here. If you open homework1 q5y, I wouldn't recommend opening X. You have all these values that are just separated by a different line. So the way you can express this is just by a space in between. So this will look at the file, and if there's a space between two values, then they'll know that they're different values. Okay, so that's a simple way to load up the homework file.
In progress.
Okay, yeah, I can enlarge the font. Hold on a minute. Yeah, so let me just copy this as a text file. So this is the code. Are you able to see it? I assume you can. This session is recorded, so you don't have to like type everything down. You can probably just see it later. Of course, one thing that I should mention is this path is going to be different for depending on where you downloaded this file to. I just saved it to a specific folder, so that's the path. Now I'm going to talk about the functions that you'll need to do homework 5. And for that, I'll share my other screen. Okay, so you want to know if you can use Jupyter Notebook. Yeah, you can use Jupyter Notebook for this class. In fact, Google Colab is a Jupyter Notebook. It's just a Jupyter Notebook running on Google server. So yeah, you can use a Jupyter Notebook if you're more comfortable with that. Okay. So Xiaofei, professor, she wanted us to talk about sklearn because sklearn is quite important for machine learning. It has all the things that you'll need for this class. You probably need a few more packages, like NumPy is very useful. Pandas, so pandas are pretty useful for importing data sets. So this is something that you would maybe want to learn. we won't cover it today, but there's a lot of nuance to pandas, and they're a very powerful tool. So you should try to use it, but that's not the topic of today. So, right, what is scikit-learn? It's pretty useful for data analysis. You can use it for data pre-processing, like cleaning your data, handling missing values, and that kind of stuff. And basically, a lot of machine learning algorithms are already written in scikit-learn, so you don't have to write them from scratch yourself. You just import scikit-learn, and then you run the functions that are already defined there. So we import scikit-learn, and from scikit-learn, we want to import linear models, because in the homework, you're going to run 3 kinds of different models, actually 2. So there's linear regression, which I don't think you run for homework 5, but you also have to run ridge regression and lasso regression. So will you import this linear model? And just because you don't want to type, so if you see here, we don't want to type linear model every time we want to call linear model, you can just import linear model as LM. Okay, so now to run a linear regression, we need to have some kind of data. So this is going to be our fake data. It's just, it doesn't really mean anything. Just, but what is X? So X is actually, Link mentioned, if we have square brackets, this is a list. So X is a list of a list. So you can see X has 3 lists, 1, 0, 1, 1, 2, 2. So what's interesting about Python or any coding language, actually, you can call elements of a list, but every element of a list is separated by a comma, and it kind of works from from outer to inner, which means like if we call X0, this is the first element in our outer list, right? So X0 will be 1, 0, and then X1 will be 1, 1, as we can expect. And Ling showed some notation. You can call the last element, which will be 2, 2. So this is the last element. So X1 minus 1. So this is 2, 2. But what if you want to call something inside here? Not that this is necessary for this part of linear regression, but just to show how you can handle lists. So we want to call the first element here, this 1. So we access the first list by X0, and then we want to access again the first element in that list. So you could do that. Or if you don't want to do like say you have lists of lists of lists, you don't want to do this, then you could do comma 0. Oops. No, okay, so this is actually not defined as a matrix, so you can't do this. So you have to access the first element in the list, and then you have to access the first element in that list. Right, so, and then the same thing for Y, but Y only has 3 elements. So you have Y0, and then Y1, and then Y2. Right, so we want to run linear regression, and to run linear regression, we have to call the linear regression function from the linear model package, so library. So to do that, we just define something like, you can call it whatever you want. Here we'll just call it regression, RAG, and then we'll call linear regression from the linear models library. So we have this, and then this next line, LM fit, is just fitting the linear regression on X and Y. I know if you guys use R, then maybe you saw a lot of LM Y X, but here in Python, X comes first and Y comes later. If you want to know, okay, if you forget, one really good thing about Python is that if you forget, you can pretty much search these things pretty easily. But in R, the community isn't well organized, and it's very confusing when you search for questions. So let me show you okay, so suppose you forget, how do you do linear regression on scikit-learn? So right, so just Google scikit-learn linear regression, and then it'll give you these things very neatly. So it'll tell you all the the function parameters, and then you have to just look at this. All you have to do is look at this and then run. And then it gives you very simple examples. So you can look at these examples and actually get a good idea of how to use this. One thing that I would mention is that you probably want normalized to be equal to false. I think it's better to standardize it first in your pipeline and then normalize, like standardize your data first in the pipeline. But scikit-learn has this thing where you can normalize the data if you need to do that for the data. In the homework, you don't have to normalize the data, so you don't have to pay too much attention to this. Okay, so back to linear regression. Okay, so we can, once we fit this linear regression, to get the coefficients of the linear regression, all you need is this, you need to call this linear regression object and then get coef, and then this is underscore. Right, so this only gets the coefficients. Also, like in statistics, we call the intercept a coefficient, but in like scikit-learn, they treat the intercept differently. So to actually get the intercept, you need to specifically call upon the intercept. So you can see that we had two columns, right? So we had 1 and 0. So these are two different columns. So we have two features. So that's why we have two coefficients for our features. And then we'll have an intercept, right? So we'll have, I guess, technically three parameters. This is our intercept parameter, and then this is beta 1 and beta 2, right? So, and then after you fit it, you could actually just use the predict function to predict a specific value, right? So here we can predict, like, let's just say 2, 1, then it will give our prediction. And you can do the same thing for ridge. Right, so you just have to call upon the ridge function from the LM library. And then for ridge, we have to specify a specific tuning parameter. So remember in homework 5, I think in a lot of the questions, you have this tuning parameter that Professor Shi asked you to specify. And here, alpha is actually the name for the tuning parameter, but you want to be careful here just because they kind of use different definitions of like the tuning parameters. And this is something that Professor Shi mentioned because in the ML community, they all have their different notations. You want to make sure that whatever you're using the same notation as what you intend to use. So to check this, you just type scikit-learn, and then let's type ridge, right? So if we type ridge, then we can see, like, okay, ridge, it's minimizing the objective function this, right? And that's actually the thing that we're using in the homework, right? So this is the objective function. And note that if you don't specify an alpha, it's going to default to 1.0. So even if you don't specify this, it's going to run something. But that might not be what you want, right? So let's say we want to run alpha equals 0.5, then it'll run 0.5. And then after you specify the, ridge model, ridge regression, everything else is the same as linear regression. So to get the coefficients, you just use the same function, and then to get the intercept, you just have to use intercept, right? So this is pretty neat. And then lasso, right? Finally, lasso. One thing I will comment about lasso is that you should be careful because the definition of ridge regression is the same, but if you go to Google and if you type, sklearn lasso, you'll see that the objective function is a little bit different. It's scaled here differently. We have the 1/2n, which is the number of samples that you have, and then alpha is just alpha. So the objective function is different. So this tuning parameter, has to be multiplied by 2n samples because that's what you want. So be careful about that when you do your homework. Otherwise, you might not get the same solution as what what the problem intended. So you have to be careful about that. So this is lasso. One thing I'll say is that, okay, like, do you want to see like how lasso and linear, like how these three different things actually have dimension reduction, like Lasso has dimension reduction. And if you want to see an effect, then you can see like all we have to do is make more features than the number of data we have. So let's just say like 1, 2, 3. And then here I'm gonna make it like 2, 3, 5. And then here we have 3, 4, 1. And this is right. So let's run this. I mean, this will most likely run. And then we get these coefficients. And then if we want to predict it, we have to say like 1, 3, 5. Right, so let's say. Right. So let's say we have this, but then let's look at what happens when we run Ridge on the same data. So we get this, and then Lasso. So you can see Lasso here actually. Ridge has the tendency to shrink things to 0, right? So we can see that these things are getting smaller, like this this last one, I guess it's beta 5, went from 0.017, and then now it's being shrunk to 0.007, right? Minus 0.007. But Lasso actually has the tendency to actually set things to 0, and you can see this in effect here. These are actually all zeros, right? So that's pretty cool about Lasso. And then you can see that this dimension reduction in effect here. Now, for the final part of homework 5, you actually have to be able to plot images, specifically matrices. And to do that, all you need is this this function from matplotlib, right? So just import matplotlib.pyplot, and then this is just an example. So what's very nice about NumPy is that NumPy has all these things about random number generators. And if you want to generate a random number, probably look at NumPy for that, numpy.random. Of course, like, okay, suppose you don't know what numpy.random.normal is. So just Google numpy.random.normal. And then you get like, okay, so you get the parameters. Location just means the mean. Right here, let's say we want mean equals 0. Scale, you have to be careful. Like, you have to be careful when you read this. It's the standard deviation. It's not the variance. So if you think the variance is 4 and you put scale equals 4, then you'll get the wrong result. You would have to put scale equals 2, because this is the standard deviation. And the size, like it depends on size is how you want it to look. So let's say if we print M here, then you could actually see that M is here a 30 by 30 matrix. Right. So maybe I want to make M smaller. So if we print M here, we can see that M is a 5 by 5 matrix. So what numpy.random.normal is doing here is just generating 25 different values that are normally generated from a normal 0-1 distribution, and then it forces it into a 5 by 5 matrix, right? But let's say you just want it linearly, then you just have to say like 5. And then it'll, okay, so we don't want this line. So we're gonna get rid of this line. Right, so if you just want 5, if you just want 5 normal random variables in a single vector, then you can just do normal 0, 1, 5. Right, but here for the problem, we want to be able to plot a matrix. So let's say we have a 30 by 30 matrix, then what you can use is just the PLT function for matplotlib.pyplot. And that's pretty useful in that, right, so I have to use C. Right, so in fact, okay, so one thing I wanted to show was debugging. Let's say like you get this error message and you have no idea what it means. For Python, like you could just Google it, and then like Stack Overflow or something will be very helpful in solving your debugging issues. So like, in fact, here it's pretty easy because we already know what the function looks like. So all we have to do is, oh no, not C. all we have to do is change this. But now, so what .im show does is it automatically generates the color coding. I don't know, some of you might be like blue-green colorblind and maybe you can't see the difference here, but like there's like, it's I guess you could use a different RGB setting, but it's just plotting various colors from like yellow to blue scale, depending on what the values are. So that's all you need to actually do the homework in this case. So this is a matrix, 30 by 30 matrix, and it's just plotting the values according to their own color scheme. Okay, so do you have any questions? Okay. I think you should use like, so I think you should use scikit-learn, just because like I think Professor Shi is going to force you to do a Python for the project. So you should definitely try to get a start with scikit-learn. We basically solved like the homework for you in this sense. Like all you have to do is change the values and import the data set. So basically the homework's done. But like I think doing this, just implementing this last step in the homework will probably get your foot, like get you started in scikit-learn. Like, don't be too afraid of it. Like I know R is very nice and neat, but in fact, Python is actually quite nice in the sense that if you have questions about how to use certain functions, the answer is usually on the internet. Right. But I think like if you use R, like we'll still grade it fine, but probably starting from the second homework will force you to use Python, maybe. Does that make sense? Okay. Yeah, so let me stop my screen share. Any other questions? Right, so this session's been recorded, so if you need to look back on, yeah, we can share the link for this notebook, and we'll share the recording. So if you need to look back on any function, then you can do that either from the notebook or through the recording. Otherwise, I think, yeah, I mean, if Ling wants to say something like concluding remarks, then I'll leave the floor
Well,
to
I
her.
think that's basically what we wanted to talk about. And anyways, maybe my final comment would be like, don't be afraid to use Python, even if you might not be familiar with it. And also, if you have questions, you can email us, and also put questions on it. And I guess that's basically what's set for today.
Yeah,
And
I highly recommend, like, if you have coding problems, post them on Ed, because I'm sure like some students in the class are Python experts, and students can help each other out in case we can't get to your question like quickly. So like definitely post these questions on Ed. I do like, don't just post the entire thing, like try to kind of summarize what your code is trying to do, but like you can post code snippets on Ed, and I think that'll be very helpful.
yeah, if you don't have any other questions, I think that will be the end for today. Not sure if Professor Shi is here. Okay, if Professor Shi doesn't have anything to say, I think that's for today. And yeah, so that's the end for today. And thank you, everyone.